Okay, welcome to the weather station. The purpose of the weather station is to show the students the many ways that weather interacts with and impacts our lives. Also the various careers that are involved with weather. The first thing we have to show you at the weather station, our exhibit, is called the Van de Graaff generator. It creates static electricity by running this black rubber belt over a plastic rod down there in the base. I want you to think about weather and tell me what this looks like. They should say lightning. Lightning is static electricity and can get over 1.2 million volts. Have you ever gotten your hair fixed just the way you wanted to and you go outside, especially in the winter, and it stands up like that? That's static electricity. Now the next thing we're going to do is we're going to have one of the students to put their hand on the top of this ball. And you notice I'm touching these two together. That's so we don't get an inadvertent shock. And then you're going to remove this smaller ball from the larger one, and you're going to talk for a few seconds while static builds up in their bodies. While they still have their hand on the ball, take the other hand and their index finger and gently touch someone quickly on the skin, preferably the arm or the hand, and they should get a little bit of a shock. Once they've done that, go ahead and touch it together again. Have that person hold hands with a second person. Remove this ball, talk for a few more seconds, then have the second person shock a third person. Now, a little bit of word of warning, if this is not working, it might be that your student is not hydrated well enough, so try another student that might be a little bit better hydrated to be able to get the shock to work properly. The next thing we have is our digital thermometer. What's really nice about a digital thermometer is you can get the temperature of something without actually touching it. So you can point it at an object. You'll see the red dot. That means that we're getting the temperature of that sign, which is 70.7, or something we might not want to touch, like the Van de Graaff, which is at 72.5. Then you can take a couple of students and get the temperature reading inside their mouth, way back at the back, and you can see my mouth is 91.4. I like to do 2 or 3 students and see which one has the highest temperature, and then I'll say, sorry, but this person is a little bit hotter than you are today. I bet you're wondering why we have a tree stump in the weather station. Not only do the rings of the tree tell us how old it is, it also tells us the history of the climate where the tree grew. This tree was chopped down in the East Texas piney woods about the end of 2012. You'll notice right along the edge here, the rings are tightly compressed. That means that they were going through a drought in the East Texas piney woods just before this was chopped down. But look, when the tree was first planted about 75 years ago, see how the rings are spread apart? That means they were getting a lot of rainfall back then. You can see there are patterns or cycles in here, and we can predict, as we did when we chopped this down, that a couple of years after that, they should start getting more rainfall and come out of the drought. Sure enough, that's exactly what happened. This right here, if you'll have someone push this all the way up, we'll get our anemometer going, also known as a wind gauge. It measures wind speed and direction and sends that information to the weather forecaster or the meteorologist so that they can get their forecast more accurately done. The last thing we have is our hydrometer. It measures the amount of moisture in the air, also known as relative humidity. The higher that number is in the summer, the stickier it feels. Have you ever noticed if you're walking with a newspaper in a couple of blocks on a summer day, it feels limp? That's because it has collected the humidity that was in the air. The next thing we have is our plasma ball, so the students can put one index finger along the ball and move it, and you'll see how it follows your finger. The reason it does that is because the human body is 65 to 72% water on average. Water is a great conductor of electricity. Now then you're going to get one student to put their finger on one side of the ball and have another student put their finger on the other side of the ball, and they can see which one of them has more moisture in their body, more water in their body. Doctors tell us if you keep your cells well hydrated, you'll typically live longer and be healthier, but we don't want to stand next to a well hydrated person during a lightning storm because they're going to be the first one to get zapped. Okay, so when you go home today, call your best friends and tell them, I held a tornado in my hands today, what did you do? If you hold this steady, you can feel the vibration in the bottle. That's why when people describe tornadoes, they often say it sounded and felt like a freight train coming. The way you start these after they've run out is you turn them upside down, you swirl them hard 4 times, and then you stop, and it should form the tornado for you. The way tornadoes form in nature is hot air rises from the surface of the earth, replaces the cooler air in the upper atmosphere, which begins to fall. As they're passing by each other, the conditions are right, it creates a swirling motion, and that's what forms a funnel cloud. Now, a funnel cloud is not a tornado unless it actually touches the ground. Less than 1 out of 1,000 funnel clouds ever become tornadoes. Tornadoes can have wind speeds of over 300 miles per hour. At that speed, it would peel the asphalt off of the roads out there and you'd have to repave them. Okay, so the last exhibit is our green screen, which technically should belong to weather, but because of its location, we make it part of aerodynamics. You're going to have the students 1 or 2 at a time stand in front of this wall and tell them that if they went to a television studio and watched the meteorologist do the weather, behind the meteorologist is a blank green wall we call a green screen, and then the cameraman projects that day's weather just like we have on the monitor over here, and this is what the meteorologist gets to look at. So you'll see them do something like this. In the Dallas-Fort Worth region today, we're going to have a high of 91 degrees with partly cloudy skies. Down in Houston, they're going to have a high of 90 and sunny skies, and you can go on and on like so. Now this green cloth right here we call Harry Potter's cloak of invisibility, and this illustrates why you should never wear green if you're going to be working in front of a green screen. So we're going to hold this up, and if you look at the monitor you can see what it does. It projects the map onto the cloth because the camera thinks that that is the background. So now I could do the weather right off my belly. Okay, volunteers, at the end of each rotation of a group of students, make sure you take the opportunity to point to the career notations at the end of at the bottom of the circular signs. They tell us what kind of careers are available and what kind of money the kids can expect to make in those careers.